Factoring polynomials using distributive property. This is lesson 8.5. The idea about factoring, what it means to factor, is to find what's common between the terms. It could be numbers or polynomials like we learned, and take out the common factor and leave what's left. Let me show you the first example with numbers. So if I have 6 and 8, I need to find the common factor between those two numbers. You have to break down the numbers. 6 is 2 times 3, 8 is 2 times 4. Notice I put the common factor in red, which means this number appears in both numbers. So the 2 repeats in both numbers, so this is the common factor. Now, if I have a polynomial of those two numbers, like 6 plus 8, so I break it down to its factors, 2 times 3, 2 times 4, and there's a plus in the middle. Now what's common is the 2, so you take it out. This is what I meant by take it out. So take out the 2, and what's left, you have to put the parentheses to indicate the multiplication, the hidden multiplication right here. So what's left is the 3 in this one, and what's left for this one is 4. So 2 times 3 plus 4 is 6 plus 8, and you can double check the math is correct. So this is the idea. Now what about if you have letters? Let's say I have this x squared and y, and x and y to the power 3 or cubed. Now to break down the x squared and y, well, x squared is technically x times x, and you have 1y. What about the x times y to the 3? You can guess that it is x with 3 y's. So now the same idea that we did with the numbers, what's common? Well, we have one x, this one is common, and we have another y. So technically the x and the y are my common factor. So xy is my common factor. Now if I want to take this out, what's left in this one? It's just the x. What's left in this one? The y and the y. So if I have a polynomial of this, two terms, we agreed that you break it down like this, and the common is xy. So what left on the first one is just the x, if you take out the x and the y, and what's left on the second one, if you take the x and the y out, is the y and the y. Well, to simplify it further, y times y is technically just y squared. So this is my factored answer of this polynomial. So it's pretty easy. Now what if we do numbers and letters? So let's do this example. If we have this trinomial, 3 terms, that has numbers, coefficients, and has p and r as letters. Well, let's do the numbers first. You have got 8, 24, and 16. You can tell already that the 8 is a common factor between those two numbers, because 8 times 1 gives you 8, 8 times 3 gives you 24, 8 times 2 gives you 16. So this is we learned before in middle school to factor the numbers. Now the letters. If you got p squared and r squared is just p times r times r. You got 2 p's and 2 r. The same goes for p to the power r 3, p and 3 r's. pr is just pr. Now you can tell that you have 1 p that is common between them, and you have 1 r that's common between all of them. So if we do the math for the factoring, we're going to notice that you have to take the 8, the p, and the r as common factors. So this is my common factor between all these 3 terms. What's left on the first one? Well, what's left is 1 and a p and a r. So 1 p and r. What's left on the second one? Well, 3 r and r. So 3 r and r with a minus sign. And the last one, plus sign, and what's left is 2 because there's no letters left. Now if you want to simplify it further, you don't have to put the 1, so it just stays pr. The 2 r's turns to r squared, and there's a plus 2. So this is the answer, the factored form of this original polynomial. Now you can double check your answer by multiplying back the common factor. So 8 times 1 is 8, p times p is p squared, r times r is r squared. So you get the idea. 8 times 3 is 24, p times nothing is p, r times r squared is r cubed power 3, and so on.